Hey guys, in this video I am going to go over this test for my second and third period Math 3 classes. If you did not do so well on this quiz, then you should get out a piece of paper and you should write down exactly what I write down for the ones that you missed. Then you can turn that paper into me along with your original quiz for some bonus points. So pay attention and write down exactly what I write down for the ones that you missed. For number 1, we have a rectangle. The length is 8.2 and the width is 7. Area of a rectangle is length times width. So all we need to do is 8.2 times 7, and 8.2 times 7 is 57.4. You could just type that into your calculator. When you do an area problem, next to the answer, you write down what everything was measured in, and you put a tiny little 2 on it. That's 57.4 centimeters squared. For number 2, we have a trapezoid, and I give you on the test the formula for area of a trapezoid. It's 1/2 times the height times B1 plus B2. In class, we learned that the height is how tall it is. It's the distance between the two parallel sides. So the height is 4. B1 and B2 are the two sides that are parallel. So in this example, they are 4.5 and 7.5. So when we go to write this down, instead of writing 1/2, I'm going to write 0.5 because that's a little easier to type into my calculator. We will have 0.5 times 4 times parentheses, B1 plus B2 would be 4.5 plus 7.5. And you can type this into the calculator exactly the way I have it written here, as long as you use your parentheses keys. If you use the parentheses keys and you type this in exactly the way I have it, you get the answer 24 inches squared. Number 3, we have to write this using exponents. So you write down the number that's being multiplied. That's the big number. That's the base. And then the exponent is how many times that number is written down. 1, 2, 3, 4, 5. So this is 9 to the 5th power. X times X times X times X times X times X times X would be X, because that's what's being multiplied, to the 7th power, because there are 7 of them. For number 4, we have -6 in parentheses written down 3 times. That means this is -6 in parentheses to the 3rd power. The parentheses are important. If you left the parentheses off, then this would have to be marked wrong, because with parentheses and without parentheses are 2 different problems. For number 6, 4 times 4 times y times y times y. We write down the 4, and we have 2 of them. So that's 4 to the 2nd power times, write down the y, and there are 3 of them, y to the 3rd power. For this one, make sure in the future that you don't write your answer like this, 4 squared times y. Because to me, when we are using variables, that times sign looks like the letter X. So I might accidentally mark this wrong if I'm not thinking. So if a problem involves variables, use the dot for multiply instead of the X. All right, I am going to pause the video for just a second to write down more problems. And I'm back. On the next page, at the top, we have to solve these problems by following the order of operations and using exponents. Numbers 7 and 8 look almost exactly the same, except number 8 has parentheses around the -6, and number 7 does not. These are 2 different problems. When you have -6 squared and there are no parentheses, that means that this squared belongs to only what is directly in front of it. That squared belongs to the 6. So you write down 6 2 times, and then you put a negative sign in front of it. So the answer to this one, 6 times 6 is 36, and it has a negative sign in front of it. The answer to number 7 is negative 36. The answer for number 8 is a little bit different. When you have parentheses and a squared, it doesn't matter what's inside those parentheses. You have to write whatever's inside those parentheses that many times. So you will write parentheses, negative 6 times parentheses, negative 6. So this one is different. There are 2 negative signs in this problem instead of just one. 6 times 6 is 36, same sign, positive. For number 9, we have negative 4 in parentheses squared plus 10 times 2. Negative 4 in parentheses squared means negative 4 times negative 4. 4 times 4 is 16, same sign, positive. So this is 16, and then write down the rest of the problem, plus 10 times 2. Now we follow the order of operations, which means we have to multiply before we can add. 10 times 2 makes 20. So this is 16 plus 20. And 16 plus 20 is 36. For number 10, following the order of operations, we have to do what's inside parentheses first. 7 minus 4 is 3. Then put that little squared on the 3. The problem is 9 plus 3 squared. In the order of operations, after you do parentheses, you do exponents next. 3 squared means 3 times 3, which is 9. Then the last step is to add on this 9. 9 plus 9 makes 18. The next section involves scientific notation. You need to write these long numbers in scientific notation. To do scientific notation, you move the decimal point from the back of the number to all the way up here. You want to move the decimal point so that it has 1 digit to the left of it, and that digit can't be a 0. Remember that for the last 3 problems in this section. So this is going to be 8.75. And when you're doing scientific notation, it's always a decimal times 10. It always says times 10. And the exponent on the 10 is the number of times you move the decimal point over. So let's see how many times we moved the decimal point to the left. 1, 2, 3, 4, 5, 6 times. So this is 8.75 times 10 to the 6th power. In the next problem, we need to write 960,000 in scientific notation. The decimal point was here, now it's here. So the decimal is 9.6. You can drop all the zeros that are behind that 6. Let me back up a second and explain why I put the decimal point here. When you figure out where to put the decimal point in the big number, you put it so that you have 1 digit to the left of the decimal point. So this is 9.6, and drop all of those zeros. Now you write down your times 10 and see how many times we moved the decimal point over. It was all the way back here, now it's here, so count. 1, 2, 3, 4, 5. I moved the decimal to the left 5 times. For number 13, we have 4,200. The decimal point is here. I'm going to move it here so that it has 1 digit to the left of it. So in scientific notation, this is going to be 4.2 times 10, and count how many times you move the decimal point to the left. 1, 2, 3, to the 3rd power. I'm going to pause the video for another second so I can write down more problems. And I'm back again. Let's go over these last few problems from the test. Numbers 14 and 15 are different than the last few because instead of being really large numbers, these are very, very small numbers. These are very tiny decimals that are less than 1. When you have numbers like that, You follow the same technique for scientific notation, but your exponent is going to be negative. When you have a tiny decimal that's less than 1, your exponent will be negative. So let's do number 14. We're going to move this decimal point. It's here right now. We're going to move it so that it has 1 digit to the left of it, and that digit can't be a 0. So I'm going to put the decimal point here, right there. So the answer is going to be 3, or you could write 3.0. Either way is fine. Times 10. And then you count how many times you move the decimal point over. We moved it from here to here. So we moved it 1, 2, 3, 4, 5 times. So the exponent is 5, but I have to put a negative sign on that 5 because this is a tiny little decimal. It's not a really big number that's up in like the 100,000s. It's a tiny decimal. So the exponent is negative. Same for number 15. The decimal point is here right now. I have to move it so that it's here. We want 1 non-zero digit to be to the left of it. So the answer will be 4.7 times 10. Count how many times you move the decimal point over. 1, 2, 3, 4, 5, 6, 7 times. And then make that exponent negative because this was a tiny little decimal. It wasn't a big number up in the thousands or the millions or the billions. It's a tiny little decimal that's smaller than 1. So the exponent is negative. Number 16, we have 8.07 times 10 to the second power. This number is already in scientific notation. The directions say to write it in standard form. That means to write it as a real number. So we have to do the opposite of what we did in the last section. Instead of moving the decimal point to the left, like we did in numbers 11 through 13, we're going to have to move the decimal point to the right so that this number gets bigger. This is a positive exponent. That means this is going to be a large number. So we need to move the decimal point over 2 times to the right. 1, 2 times. Your decimal point is here now. But I can't just write this as my answer because the way it's written right now, it has 2 decimal points in it. I need to rewrite my answer as 807. And you can put the decimal point in the back if you want to, or you can just leave it off. It can be invisible. But you can't keep that one there. You can't keep the decimal point there. For number 17, this is a positive exponent, which means this is a large number. It's not a tiny little decimal. It's going to be a big number. So I have to move the decimal point to the right so that this becomes a big number. And I need to move it to the right 4 times. So 1, 2, 3, 4. I'm going to have to put a 0 in this ditch right here. And then I have to rewrite my number. This is 45,010. Don't put the decimal point there. You can put a comma if you want, as long as you make your comma look like a comma and not a decimal point. For number 18, which is right here, we have to move the decimal point to the right because this is a positive exponent. We want this number to get bigger. So we're going to move the decimal point to the right 8 times. Let me rewrite this. 2.73, move the decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. We need to put a 0 in each of these ditches. And then we need to rewrite our answer because this is very sloppy. I don't know if you want the decimal point to go there or there or there. So you have to rewrite your answer so that it's clear. 273,000,000. You can put the decimal point at the end if you want, or you can make it invisible. Number 19 is 3.42 times 10 to the negative 5th power. Remember what I said about those negative exponents? When the exponent is negative, that means you have a tiny little itty bitty decimal that's less than 1. You don't have a really big number that's up in the thousands or the 10,000s or the millions. You have a small decimal. So since this says -5, I'm going to have to move the decimal point to the left because I don't want this number to be really big. I want it to be tiny. So I'm going to move this decimal point, and let me rewrite it, 5 times to the left. 1, 2, 3, 4, 5. Put a decimal point and put a 0 in each one of those ditches. And again, don't leave your answer sloppy like this with ditches underneath. Rewrite it so that I know exactly where you want your decimal point to be. With little decimals like this, if you would like to put a 0 to the left of the decimal point, you can, but you don't have to. You can leave it off if you want. Last one, 9.071 times 10 to the -6th power. Remember what I said about negative exponents. We have to move the decimal point to the left, and we're going to move it to the left 6 times. We want this number to be an itty-bitty, tiny little decimal like this, so the decimal point needs to move to the left. So let me rewrite it, 9.071, and count to 6 with me. 1, 2, 3, 4, 5, 6. There it is. I'm just going to rewrite it so that it's nice and neat. It's point, how many zeros? 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5, 9071. And that, my dears, is our quiz. If you did corrections and you wrote down the things that I wrote down for the ones you missed, make sure that you turn those into me. Make sure that you have your name on them, and make sure that you include your old quiz. Bring your old quiz and your corrections with your name on both and hand them to me as soon as possible before you lose them. All right? Have a good day, everybody. See you soon.